Today, AI systems are incredibly powerful, but they are largely centralized. They rely on cloud infrastructures, operate in isolation, and often requires users to share sensitive data with the third-party services. This creates challenges in privacy, scalability, collaboration, and data ownership. AEGIS is our vision for solving this problem. Rather than building another AI chatbot or a single AI application, we are building a distributed AI platform that enables intelligent systems to collaborate securely by keeping users in control of their own data. Every AEGIS session begins by starting the runtime daemon. This daemon acts as the foundation of the platform. It initializes the runtime kernel, load the core service, start the distributed intelligence engine, and prepare the AI runtime for intelligent task execution. Rather than launching a single AI model, AEGIS boot an entire operating environment. During startup, the runtime initializes the platform modular architecture, including memory management, event handling, engineering, lifecycle management, and communication with the native C++ distribution intelligence system that the logs can see here. Agent Agent dashboard, which provide a real-time view of the platform. Agents are working here. They can create or delete new sessions like this, adding new sessions or deleting that section. That sections will go to the trash folders. We can safely restore or delete the section permanently from here. We can add tools or skills or plugins to the agent. Only with these tools and skills, the agent can perform real-world tasks. So this is how we can add a tool, and this is how we can remove a tool. Same for skills and plugins. The Aegis is a modular architecture, so everything can be done in modularity. Many users can make their own skills and tools and plugins from their own. So we provide a small template about how to make the skills, tools, and plugins. This template helps to know how to make plugins or how to make providers like the Olama or GGUF or API, something like that. You can add more providers or delete the providers, and everything is documented here. So this template helps to add more and more tools like in the user side, from the user side. The workspace is allocated to the agent so that only tasks that or creating files or deleting files or doing tasks like creating a website all are done here. The agent want to do some task outside the workspace, it needs extra permission. So the user want to give that permission. So we can view how the boot file and the runtime is running by checking by the runtime status. A package manager is there, that is Aegis package manager that manages all the packages in this. So we are implemented all things like the runtime, the memory, the distributed intelligence, all are in packages. This is the Aegis distributed intelligence system which helps to run the Aegis even in IoT devices. It does not need a large processing power or runtime ecosystem. To show this how the Aegis federated learning works, we added a small prototype named mini project in this project. So and a federated project inside that. We created this federated learning interface to show or demonstrate the federated learning because this project is purely based on architecture and we can build anything above this. So this is the server interface and this is the client interface. So we can tap the send encrypted LoRa to send the LoRa to the client side or the from the client side to server side. Now we can create another client by simply copying this client and pasting it and rename it to any other client name, like client B. So the client B is created. This much simple the system is. We can move to the AEGIS website. There are a lot more things to do in this website. So anybody can read it, which is publicly available in this website that I already provided in uh, the submission of project. AEGIS website has a bit banner also. So now my system is already logged in. So this is that. Otherwise, this is a password protected panel. So we can directly do much more things in there. So there is no time to explain a lot of that. But I can show you one important thing that we can customize the website without writing a single line of code. So we can customize all of this. For example, uh, now there is a hero section uh, in the edges website. So we can go to that side and see that this is the hero section. So we just want to hide it and save the builder. That's all it. The edit section will hide from all the platforms and all the browsers. That is the beauty of the website. And you can do a lot more things like contact, the API generation, the revenue, and much more. And there is also a dashboard for the users. So there are also the download request and all other things. And this is also a password protected. And we can just log out. After that, we want to log in again for that. Pages is a customizable platform or an operating system for the AI environment, anything you can call. But yeah, the user can customize if they want a request access API key, node, registry, and if they want downloads the Aegis agent, Aegis server, Aegis client, Aegis uh, CLI, all they can download independently and run independently. That is the beauty of Aegis. But every user needs to request because for the agent or the AEGIS. So there is an approval for the admin. The admin check and approve for the files. So structure is very important and this modular. So there is a package manager and AEGIS package manager that all manages all the packages like the AEGIS agent, AEGIS API, AEGIS distributed intelligence. That's the main part of this uh, program. It can run independently in any systems like in even IoT devices. The AEGIS runtime is the part where coordinating the AEGIS distributed intelligence and AEGIS agent, AEGIS API, memory, and etc. So now we can move to the memory part. The memory part is more important because the memory is a self-evolving thing in there. So there's episode memory, index memory, profile memory, and sections. The sections is that we are created in the agents. Then these are the sections, and these are the trash files. In every section, in each section, there is a section memory and a working memory to achieve a goal. And some section memory, the agent itself create a task.md to perform their goals. If the performance or the goal is a large one, for the say more than two or three simple steps. Now we can move to the engine bar. All these are formulated and built in a top of the engines. Each engine can connect and run independently, but the runtime is essential for that. The next part is the templates. We provide templates to build the plugins, providers, skills, and tools. So the a developer can read it and make their own skills and tools. They don't need to rewrite the whole code to add or remove any tools or skills. They only need to take the template and make skills and just put the skills and tools in the respective folder. The skills and this is the tools and this is the provider and this is the plugin. Because the time constraint, we are not going to deep or much more, but the federated learning report is very important. So the federated learning means without the model is training or a large language model is building their knowledge evenly more. It is a fine-tuning technique or a more learning technique that the data is absolutely trained inside any devices in this system. Any constraint, resource constraint devices can train their model and send only the low ranking adapters, the LoRa, to the server. So no thing is going or the no data is going out from the devices. All other things, other memory situation, all are documented currently and anyone can read it. So the architecture review, architecture diagram, memory subsystem, modular referring, all are documented. So this is a project. You can view the website for more details or just go to the dashboard or fill the form. Then you can get the packages of the edges and the GitHub repository is all available to open source. Thank you.